This Excel demonstration is using the same Excel workbook as the last demonstration. This one's using Excel demonstrations, the standard normal curve. So what we want to talk about with this one is finding a z-value when we're given the area. So now we're given the gold area under the normal curve. So now we know what this area is, and I'm trying to find the z-score. So, or the z value. And so I'm trying to find z in these calculations. This is opposite. This is the inverse of what we did when we found the areas under the standard normal curve. So the function that I'm going to use is the inverse standard normal curve function. So up here at the top, we would pick, so let's say inverse standard normal. Go. So we're going to use this second one down, the one that has the periods in it, norm.s.inverse. Returns the inverse of the standard normal cumulative distribution, where that standard normal distribution has a mean of 0 and a standard deviation of 1. So that's the function that we're going to use in this demonstration. So the first one, so let me cancel this. The first one says, find the z-value given the area is to the left of z. So I shaded it in, I made it gold, and so this area, this gold area is 0.717. So now what I want to do is I want to find that z-score that goes with that. So I want to find that z-value. So let's go and let's use that distribution. The norm S inverse. Okay. And now we're going to put that probability in there. So we're going to put that probability of 0.717. It has an inferred 0 at the end, with trying to stay with the convention of 4 decimal places, but the problem asked us to do 0.717. Okay, so that area, the z-value that goes along with the area of 0.717 is 0.57. That's the z-value, and the z-value is 0.57. The next one down here says find the z-value given the area to the right. So the area to the right, so now I've got this shaded in gold over here, and so now this area is 0.894. So the area in gold is 0.894. I'm trying to come up with the z-value. So this time, so again, remember, I'm thinking about the complement, because when I type that area, that 0.717, the tables and the Excel commands know that we're talking about the area from the left all the way up to this z-value. So we want the complement again. So we're given this one. And so when I use this command, I'm going to say equals norm.s.inverse. So I want it to do the inverse normal of the complement, 1 minus 0.894. Negative 1.25. So that's my z-score. It's negative. It's on the left-hand side of the standard normal curve, and that z-score is negative 1.25. We could have, if you would have felt more comfortable, we could have said 1 minus 0.894. And that would have been the area that went along with this blue area. And then we could have said equals norm dot s dot inverse of this. So we could have done that calculation first, and then let's make sure that the rounding is right. So when we're doing z-scores, we want to go to the 2 decimal places. So negative 1.25. So I get exactly the same answer. In the first case, I was just letting Excel do all the work. In the second case, I did the calculation first to find out what that blue area was, and then I did the inverse distribution. Last example. So the last example says, find the z-values given the area is between 0.950. So find the z-value given that the area is sitting in the center between negative z and a positive z. So it's centered at the mean, 0.950. So now what happens is I need to look at this one in the case that I'll say 1 minus 0.950. So that's the remaining. That's the unshaded area. So the unshaded area, but because it's centered at the mean, I have half of that area in the left tail and the other half of the area in the right tail. So I'm going to take this value and I'm going to divide it in half. So I'll say equals this divided by 2. So 0.025. So on the left, so where I'm at negative z, that area from the tail up to negative z is 0.025. On the other side, at the positive z, that's going to be 0.950 plus this piece, right? So 0.975. So the z-score that goes along with this one, let's calculate that. So it says find the z-value given that area. So the one z-value, so we'll say equals norm S inverse of this. And then we'll fix the rounding. Then on this one, we'll say exactly the same thing. So this is the value, this is the negative z. So the negative z is 1.96. The positive z, so by symmetry, wouldn't I guess before even doing the work that it's going to be plus and minus 1.96, that z is going to be exactly the same on the two sides because the 0.95 is centered at the mean. So let's take it and let's check what we guessed. So equals norm S inverse and then let's fix the rounding. So it's exactly what we thought. So on the other side, the z-value is 1.96. So our z-value is 1.96, one of them being a negative 1.96 and the other one being a positive 1.96.